Hi dears, we are starting with definite integrals, exercise 16a. First question, integral pi by 4 to pi by 2 cot x dx. Like how we used to do in the indefinite integral chapter. Same methods we follow. After integration, we make use of these limits. Okay. We know the integration of cot x is log sin x, isn't it? So log sin x. Don't write plus c. The plus c is to denote the arbitrary constant, but here we have the limits. So we don't want to write plus c. Instead, we write the limits here. After integrating, we use upper limit minus lower limit. That means wherever you have that variable, substitute the limits whatever given in the question. First the upper limit. So log sine of pi by 2 the whole minus log sine of pi by 4. Pi by 2 is 90 degree, sine 90 is 1. So it is log 1 minus log sine pi by 4 is sine 45 degree, that is 1 by root 2. So log 1 is 0, 0 minus log 1 by root 2. This we can write it as log. We can take this root 2 to the numerator. So we can write it as 2 power minus half. Take this minus half as a product using the logarithmic property. Minus half into minus 1 is plus half. Log 2 is the final answer. Question number 2. Integral pi by 6 to pi by 3 dx by sine 2x. We try to take the sine 2x to the numerator using the trigonometric property. So integral pi by 6 to pi by 3. This 1 by sine is cosecant and the argument we have 2x. And we know the integration of cosecant x is log tan x by 2. But in place of x we have 2x. So 2x by 2. Okay. The whole by the coefficient of x is 2. We write it as 2. And instead of plus c, we write it as pi by 6 and pi by 3. Let's take this 1 by 2 common out and we write upper limit minus lower limit. Before that, we can cancel. Since it is inside the argument, we can cancel. Now, upper limit minus lower limit. So, let this half be common outside. So, log tan upper limit is pi by 3 minus log tan pi by 6. Tan pi by 3, that is tan 60 degree is root 3. That means log root 3 minus tan pi by 6, that is 30 degree, 1 by root 3. So log of 1 by root 3. We make use of the logarithmic property, log a minus log b. Log of a by b, isn't it? So 1 by 2 log a is root 3, b is 1 by root 3. We just substitute as it is. Now the denominator is in a fractions and we take the reciprocal. That will become root 3 by 1. Already root 3 in the numerator. Root 3 into root 3, 3. Half log 3 is the answer. It's actually first subdivision, second subdivision, third subdivision, sorry. Integral 0 to pi by 4, 2 secant square x plus x cube plus 2 dx. Either you can separate all the three terms into three integrals, you can do, or inside this integral itself we can do. Okay. Integration of secant square is tan x. So we have 2 tan x as 2 is in product. And x cube is x power 4 by 4. 2 into dx, it will be 2x. Now the limits 0 to pi by 4. Now the upper limit minus lower limit. Wherever x we have, substitute the upper limit. That is 2 tan pi by 4. This 1 by 4 we write it separately. X power 4, that is pi by 4 the whole power 4. 2 into pi by 4. This is the upper limit. The whole minus, the lower limit is 0. 2 tan 0 plus 0 by 4 plus 2 into 0. When we solve, tan 45 degree is 1. 1 into 2 is 2 plus 1 by 4 into pi by 4 the whole by 4 power 4. Here this gets cancelled, that is pi by 2. Tan 0 is 0. These two are 0 by any number is 0. 0 into any number is 0. So the whole lower limit value will be 0. Isn't it? Now 4 into 4 power 4 will be 4 power 5. 2 plus pi by 2 plus pi power 4 by 4 power 5 is 1024. This is the final answer. Subdivision 4, integral 0 to pi sin square x by 2 minus cos square x by 2 dx. I am taking minus common. Okay, 0 to pi cos square x by 2 minus sin square x by 2. As plus sin square, when we take minus, it will be minus, this will be plus. Because we make use of the formula cos 2x as cos square x minus sin square x. So this formula we are making use here, but the argument is by 2, so divide by 2, this will be cos x. So just we are dividing, since we have cos square x by 2, this means dividing the argument by 2. So 2x by 2, it is x. We replace the formula, integral 0 to pi cos x dx. Integration of cos x is sin x and the upper and lower limit is 0 to pi. Now this minus, let it be common out. Now it is sin pi minus sin 0. Sin 0 is 0, sin pi is also 0. 0 minus 0 is 0. Whatever the plus or minus, 0 is the final answer. Question number 2, first subdivision, integral dx by 2x minus 3 and the limits are 0 to 1. We know the integration of dx by x is log x, isn't it? Here in place of x we have 2x minus 3. As the degree is 1, we can write this integration as log of 2x minus 3 and the limits 0 to 1. As we have integrated, we write upper limit minus lower limit in the next step. Wherever x, substitute the limits. So 2 into 1 minus 3, this is the upper limit, minus log 2 into 0 minus 3. This is the lower limit. And one more thing I forgot here, the whole by, we have the coefficient of x is 2, yeah, that we have to write. Okay, let we write it as 1 by 2 as a whole into. Okay, so 1 by 2 into, this resembles log m minus log n, isn't it? Log of m by n, that we can write log of 2 minus 3, that is minus 1. 2 into 0 is 0 minus 3 is minus 3. Minus minus gets cancelled. So the answer will be 1 by 2 log 1 by 3. Subdivision 2, integral 1 to 3 dx by 7 minus 2x. It is similar to the previous subdivision. We make use of logarithmic formula again. So integration of dx by 7 minus 2x will be log 7 minus 2x and the coefficient of x is minus 2. So we write it as minus 2 and the limits 1 to 3. Okay, let's take minus 1 by 2 common out. Now let's substitute the upper and lower limit. That is, upper limit is log 7 minus 2 into 3 minus log 7 minus 2 into 1. Now it is of the form log m minus log n. So we write it as log of m by n minus 1 by 2 log of 7 minus 2 3s are 6. Yeah? 7 minus 6 is 1 by 2 1s are 2. So 7 minus 2 is 5. So it is minus half log 1 by 5, or we can take this 5 power 1 to the numerator as 5 power minus 1. Now we make use of the formula again, that is log m power n can be written as n into log m. That is the property we are making use here. So minus 1 into minus 1 by 2 is plus half log 5 is the final answer.